G'day students. Okay, in the first video, we gave you a brief introduction to what it means to solve a linear equation, and then we did some examples where we solved some one-step equations. So what we're going to do now is extend that to solving some two-step equations. Now, before we do that, let's just have a look at the same lad that was wearing the raincoat before. So when he gets up in the morning, he's got bare feet. And to get dressed for school, one of the things he has to do is put on some socks. So socks on. Once he's got his socks on, he can put on his shoes. And finally, once he has his shoe on, he ties the laces. And then he's ready to head off to school. And there's an order of operations for this. You've got to put your socks on before you put your shoes on. You've got to put your shoes on before you tie the laces. Now, when he comes home after school, assuming he wants to be running around barefoot, what he has to do is undo these steps, but he has to undo them in reverse order. So the first thing he has to do is untie his laces. He then has to take his shoes off. And finally, he takes his socks off. And he's back to the way he was when he got up in the morning. So the important thing here is, here's the order of operations for putting his socks and shoes on in the morning. Here's the operations for undoing that. And the important thing is he has to undo it in reverse order. He has to untie his laces before he takes his shoes off. And that is what we have to do when we're solving equations. So the normal order of operations, when we're doing, if we've got multiple operations in one expression, we do what's inside the brackets first, any operations in there. We then do any indices. So if you're looking at algebra, it'd be like a to the power of 2, or with numbers 3 to the power of 2. The next step in order of operations is multiplying and dividing are equal. You do those left to right. And finally, adding and subtracting are equal. You do those left to right. And when you're solving equations, you have to undo the order of operations. So the first thing you have to do when you're solving equations is undo any adding or subtracting. After you've done all of those, you then undo all the multiplying and dividing. You then undo any indices or powers. And the last step is you undo the operations that are inside the brackets. And I just abbreviate that as AMIB. So AMIB is the secret to solving equations. Okay, let's have a look at 4 examples. So here I've got an unknown number, and it's got 2 operations done to it, multiplying by 2 and adding 12. Well, AMIB says to us that we have to undo the adding and subtracting first. So the first step I have to do is take away 12. And as we did in our first video, that has to be done to both sides of the equation. Add 12, subtract 12 just gives us 0. And 2y plus 0 is just 2y. Sometimes we just call that canceling out the plus 12. And 6 subtract 12 is negative 6. Second step, notice by the way, we now have a one-step equation. So every time we do one step, we reduce the number of steps that we have to still do. So I've got to undo multiplying by 2 by dividing by 2. 2 divided 2 is equal to 1, and 1 times y is just y. And negative 6 divided by 2 is negative 3. Negative divided by a positive is a negative. Okay, let's do a quick check to make sure that that was done correctly. So 2 times negative 3 is negative 6. Negative 6 plus 12 is 6 or positive 6. So that's correct. Okay, looking at the second example, again, the 2 operations is a multiply and a divide. So in this case, we don't have any adding and subtracting, but we do have both a multiply and a divide. We could do either of those first, but I always like to get rid of the fraction as soon as I can. So I'm going to start by multiplying both sides times 3. And I'm just going to use the dot for multiplying because I use the times there. It might look a little bit too much like the letter X. So 3 divided 3 is equal to 1, and 1 times 2p is just 2p. Negative 8 times 3 is negative 24. We now have a one-step equation. The opposite of multiplying by 2 is dividing by 2. 2 divide 2, again, we can just say they cancel out, or you can say they divide to equal 1, and 1 times p is just p. Negative 24 divide 2 is negative 12. Okay, let's do a quick check on that one. 2 by negative 12 is negative 24. Negative 24 divide 3 equals negative 8. So that's also correct. Okay, third example. Here's our two operations. We've got a divide and a subtract. AMIB tells us the first thing we have to do is undo the subtraction. We do that by adding 6 to both sides. Minus 6 plus 6 equals 0, and k on 4 minus 0 is just k on 4. 10 plus 6 is 16. Okay, to get rid of the divide 4, we multiply by 4. We multiply by 4. The 4's cancel out or divide out, and k equals 64. Again, we'll do a quick check on that. 64 divide 4 is 16. 16 minus 6 is 10. So that, in fact, does give us the correct answer. Okay, with this last equation here, I've actually deliberately put the variable in the second term. Now, because this is addition, it's exactly the same as 3m plus 8. The order doesn't matter. So to solve this equation, once again, I have to undo adding and subtracting. So I just take away the 8 from both sides, like so. 8 minus 8 cancels out, leaving just 3m. 17 take 8 is 9. And the last step to solving the equation, the opposite of multiplying by 3 is dividing by 3. And the solution to this one is m equals 3. Again, a quick check. 3 times 3 is 9. 8 plus 9 is 17. So there's 4 examples of two-step equations. Okay, what I'd like you to do now is to stop the video and have a go at doing these 4 questions on your own, showing all your working. And once you finish, turn the video back on, and we'll go through the answers fairly quickly. Okay, welcome back. Hopefully you've done all your setting out for these questions. 2 operations in the first equation is multiply by 3 and add 9. So the first step you should have done is to subtract 9 from both sides. That leaves 3y equals 9. And second step, the opposite of multiplying by 3 is dividing by 3. And I get y equals 3. Check. 3 times 3 is 9, plus 9 is 18. So that's the correct answer. Once again, we've got a multiply and a divide there. My preference is to undo the divide by multiplying by 2 on both sides. That leaves me with 4x equals negative 12. Divide both sides by 4. And that leaves me with just x on the left. Negative 12 divide 4. Well, negative divide positive is negative. 12 divide 4 is 3. Okay, let's do a quick check on that one. 4 times negative 3 is negative 12. Negative 12 divide 2 is negative 6. So that's correct. Third problem, we first undo the subtracting 2 by adding 2, and they cancel out. And we end up with g over 3 equals 6. The opposite of dividing by 3 is multiplying by 3. The 3's cancel out, and g equals, oh, what did I do there? Let's see, divide by 3. I better go and fix that up, I think. Okay, sorry about that, guys. I'll go ahead and redo that. So 4 plus 2 is 6. And then I have to multiply by 3, not times 6. And that gives me g equals 18. Okay, let's check to see if that's correct, having made that mistake. 18 divided by 3 is 6. 6 minus 2 is 4. Yes, so that is correct. And finally, I've got 12 plus 2h on the left. Well, that's no different to 2h plus 12. So I can still undo the adding by subtracting 12 from both sides. And that leaves me with just 2h on the left. And 30 take 12 is 18 on the right. And the opposite of multiplying by 2 is dividing by 2. The 2's cancel out. And the answer is h equals 9. Quick check, 2 times 9 is 18. 12 plus 18 is 30. And that's correct. So in summary, if you have two-step equations, you just use AMIB. You undo all the adding and subtracting, then you do the multiplying and dividing, then you undo indices, and finally you undo brackets. So in the next video, we'll just look at some slightly more complicated two-step equations.